Hello everyone, welcome to the ITLS Academy. Today we are going to discuss about the determination of the water hardness with the help of test strip. In the previous lecture, we are already discussed about the what is the hardness of the water, why we do this hardness of the water, and the first method that we use for the determination of the hardness water is the EDTA method. That EDTA method, the video related to this are already uploaded in our account. Here what we are going to do, we are using the test strips for the determination of this water hardness. Okay, now the next one is objective of this experiment is that determine the hardness of water by contact test strip. Okay, the strip that we are using is what? Contact test strip. Contact test strip. So with the help of this test strip, what we are going to do, we are going to determine the hardness of water. Now the principle behind this the test strip, principle behind this experiment are what? The test strip that we used in this experiment are what? They are a paper, and this paper are mixed with a chemical into it, and it will also adhere a polystyrene. Okay, and the major chemical present in the matrix of the paper are what? They are a calamine and the EDTA. And along with this major matrix of the chemicals, some minor chemicals are also added so that the reaction time should be minimized. And it also give a long-term stabilities and also maximize the distinction between the level of water of hardness by giving different color. Okay, so what we have to do, we dip this strip into a water so that total hardness of the water can be determined, and it can be determined by the presence of the calcium and magnesium. Okay, this calcium displaces the magnesium bond which is formed to a EDTA, and then release the magnesium, and this when this magnesium are released, it form a bond with the calamine, and this create a change in color of the test strip. Now see what is written in the slide. The test strip have a paper impregnated with a chemical that is adhered to a polystyrene for ease of handling. The major chemicals in the paper matrix are calamine and EDTA, and minor chemicals are added to minimize the reaction time. Okay, why we added this minor chemical? So that the reaction time should be minimized and give a long-term stability, and also maximize the color distinction between the level of water hardness. The strips are dipped into the water to test for total hardness caused by a calcium and magnesium. The calcium displaces the magnesium bond to EDTA, and it releases the magnesium bind to a calamine, and it causing the test strip to change the color. This is the principle behind this experiment. Now the chemical that we use for this experiment are, the first chemical is your calcium carbonate. Okay, the first chemical is what? Calcium carbonate, and its case number is what? Its case number is 4713431, and the hazard associated with this calcium carbonate are what? They are harmful in nature. Okay, and the second chemical is used is calamine. They are what? 3147-414-6, and the hazard related to this chemical are what? They are irritant. Okay, now the next one is your ethylene diamine tetraacetic acid disodium salt. It is case number 6000-4. They are also irritant in nature. Okay, this ethylene diamine tetraacetic disodium salt formula are what? Its formula are Na2EDTA.2H2O. Okay, hydrochloric acid concentrated, HCl. 7647-010-0, and the hazard related to this is what? They are corrosive in nature, and other proprietary chemical in test strip. Okay, so all the other chemicals are present into a test strip, but the major chemical that we use in this experiment are this one. Okay, now the next one is what? Reagent preparation. Okay, the first reagent that we required first, or you can say the only reagent that we required, is a calcium standard solution 1 milligram. Okay, so for this what we have required, we required a calcium carbonate. So prime, what we have to do, we have to use a primary or a special reagent in which they have a low metals like alkali and magnesium. What we have to do, we dry this calcium carbonate in 100 degrees Celsius for 24 hours. After 24 hours, we take a weight of calcium hydroxide of 1.0 gram, and it 1.0 gram is transferred into a illuminally flask of 500 ml. Now we place a funnel into this neck of this illuminal flask, in which this 1 gram of calcium carbonate are present, which are already dry. Now after that we add a HCl plus H2O, and the concentration of HCl and H2O is 1:1 until all the calcium carbonate are dissolved. Now after that we add 200 ml of deionized distilled water for their mixing. Now on after few minutes, carbon dioxide are expelled. Okay, when we added this deionized distilled water. Now we have to adjust this pH around 3.8 with the help of ammonium hydroxide or HCl H2O. Okay, as required. Okay, then after that we transfer all the quantity to into a 1 liter of volumetric flask, and then we dilute it with the volume with deionized distilled water. That is 1 ml is equal to 1 milligram of calcium carbonate. Okay, now see what is written in the slide. Use primary or a primary standard or a special reagent that is low in heavy metals, alkali and magnesium. Dry calcium carbonate at 100 degrees Celsius for 24 hours. Accurately weigh amount of calcium carbonate is about 1.0 gram. Transfer to a 500 ml of Erelmier flask. Place a funnel in the neck of the flask and add HCl 1:1 concentration of HCl H2O, a little at a time until all the calcium carbonate has dissolved. Now make sure all the calcium carbonate in the neck of the flask has been washed down with the HCl. So if it is any traces of the calcium carbonate are in their neck, then it should be washed with the help of this HCl. Now you have to add 200 ml of deionized distilled water and boil until a few minutes so that CO2 will expel out. Now we have to cool down and adjust its pH 3.8 with the 3 molar of ammonium hydroxide or HCl 1:1 concentration like HCl issue H2O as required. Now transfer the quantitatively to a 1 liter of volumetric flask and dilute to a volume with deionized distilled water. 1 ml is equal to 1 milligram of calcium carbonate. Now the next one is your hazard precaution and waste disposal. Okay, hazard precaution and waste disposable. So we are using the test strip, so no precaution are needed. Another normal laboratory procedure we have to follow. Waste should be drained using water rinse, and good laboratory practices should be followed so that it will not affect the environmental health, and other safety protocol which are provided by our institution should be follow. Now see what is written in the slide. And one more thing we have to follow, that the chemical that we use are irritant in nature and corrosive in nature, and so that we have to avoid to these chemical to come in contact with our body. We also have to wear proper gloves and proper gloves and proper lab coat before performing this experiment. Now see what is written in the slide. No precaution are needed in use of the test strip. Okay, adhere to a normal laboratory safety procedure. Waste likely may be put down the drain using a water rinse, but follow a good laboratory practices outlined by a environmental health. Okay, when we are drain out this waste with the help of this water rinse, so we have to make sure that the environmental health should not be disturbed, and other safety protocol at your institute should be followed. Now the material that we use for this experiment are what we required: a aquacheck test strip. Okay, this is the test strip name, that is your aquacheck. Environmental test system inc, a hat company, Ilkhart in. Okay, this is the name of the company who manufacture this strip. And we also required 2 beakers of 100 mls. Now the next one is your procedure. See, the procedure for the formation of this calcium carbonate are already discussed in the previous lecture. You can go and check with how we prepare it, how we sterilize it. Here what we have to do, we take a standard calcium solution and dip the test strip into a beaker filled with water. Okay, suppose that this is your cylinder, in which either a water sample or either a standard calcium solution. So what we have to do, we take a strip and just dip into it, and we have to follow the instruction which are already given into the strip, and how to read it according to their color to the ppm. Now we convert this ppm of calcium carbonate as determined with the test strip to a milligram and gram of calcium per liter. Okay, so this is very simple, that suppose that some ppm are there, so this that ppm are relate to the ppm given into the, sorry, color to the ppm given to the, suppose that we have a orange color in our ppm, sorry, in our strip. Okay, or not a orange, we have a violet. Okay, if we have a violet color in our strip, now this color should be relate to the ppm present into a strip instruction. Okay, now after that ppm are converted into a milligram of calcium carbonate per liter or gram of calcium per liter. Now see what is written in the slide. Dip the test strip into a beaker filled with the water or the standard calcium solution. Now the follow the instruction on a strip about how to read it and relating color to a ppm calcium carbonate. Now convert this calcium carbonate as determined with the test strip to a milligram of calcium carbonate per liter and gram of calcium per liter. So this is the procedure. Now the data and calculation. Here the tap water, what we have a sample, we have a tap water, we have a tap distilled water, we have a standard calcium solution. Okay, now for all we have to, suppose that here the respective ppm calcium carbonate, here the respective milligram calcium carbonate per liter, here the respective gram of calcium per liter. This is all we have to relate to the instruction given into a strip. This is how we calculate the calcium carbonate or milligram of calcium carbonate per liter, or amount of the calcium per liter present into a water. This is all about the determination of the hardness of water with the help. I hope you have I hope all the doubt of you have clear all your doubt. If you have any query, just let us know in a comment box. Thank you for watching. Please like, share and subscribe. You can also ask your query to the helpline number that are already mentioned in your PPT. You can also follow the ITLS Academy, or you can also visit our website, that is www.itlsacademy.com. You can also follow the ITLS Academy on different platforms like Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and also subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Thank you so much. If you have any query, just let us know in a comment box.